So what we had a look at the other day was a scenario where we found a discriminant and it had a variable k or m in it. And what that means is we could have a different value we put in, and that determines whether we have one root, whether we have two roots, or whether we have no real roots. And obviously we know that our discriminant is b squared minus 4ac as it relates to ax squared plus bx plus c equals 0. Okay, that's our discriminant. If our discriminant is greater than 0, we've got two roots. If our discriminant is less than 0, we have no roots. And if our discriminant is equal to 0, we have one root, or we say that we have equal roots. Okay. Another way we can put it up here for two roots, we can also say that they are different roots, different real roots. Okay, but that's the scenario where we have it thus far. So, the question we're going to look at today is find the value of k, and in fact its values, such that x squared plus k plus 3 x minus k equals 0 has real roots. Okay, alright, we've got a little bit to work with here. So first of all, I would go and write down my values for A, B and C, because they don't leap out at you, they're not just straight numbers this time. Our A is 1, that's easy, we've got a 1 in front there. Our B is k plus 3, and our C is negative k. Alright, so we're going to go and write down our value for our discriminant now. So our discriminant, of course, is b squared minus 4ac. So we decided that our b was k plus 3 minus 4 times 1 was a times negative k was c. So let's go and find out what we get when we expand this. We get k squared plus 6k plus 9. That's just the expansion of the left. Minus 4 times 1 times negative, well, that's plus 4k. Okay, so what I'm left with is k squared plus 10k plus 9. Alright, now what did we need here? We needed two real roots. Well, I hope you, sorry, we needed real roots. Well, we decided that when our discriminant is greater than 0, we have two real roots. And if it's equal to 0, we have one real root. Well, I hope you see the scenario we're actually looking for is this one. Because if we have one real root, we still have a real root. So what we're looking for is to solve where that guy is greater than or equal to 0. So it's the combination of those two scenarios actually. So what I'm going to go solve is k squared plus 10k plus 9 is greater than or equal to 0. And I hope you see that our quadratic inequality comes back in here. So I can factor that. It's, pardon me, k plus, well, multiply to give 9, add to give 10, pretty straightforward. Greater than or equal to 0. Alright, let's draw ourselves a quick sketch. Again, I'm not interested in the vertex, I'm not interested in the y-intercept, although I could find them. But what I've got is roots at negative 1 and negative 9. I am concave up. Alright, now where is this blue line above the axis? Above the x-axis here. Where is y positive? I hope you see it's that bit, and it's that bit. So what I've got here as my solutions is that k is less than negative 9, or equal to negative 9, and k is greater than or equal to negative 1. Now if I pick some values here, if I go put in a value of k as 3, back into my original equation and found the discriminant, I'd find it would be positive. But the same deal if I pick negative 12, because that'll be over here somewhere. And 3 would be up here somewhere. But if I pick something like negative 4 in the middle there, what you'd find is that I couldn't actually have some real roots. I would have a negative discriminant, and I would have unreal roots. The blue line represents our discriminant. Okay, so it's almost like a parabola of a parabola, but I hope you can see the method that we're doing here and how the answer that we found actually makes sense. Can we get this written into our theory books, please, and then we'll do some questions.